Well, all of this is just to say that what we're trying to do is to take the idea of sort of understanding how simple structures fit together and come up with some way in which to make it interesting to creative people. That if you're open to thinking of it in new kinds of ways, that the interconnectedness of geometry, it's like this really unique human inquiry where words and things, ideas and things are all in the same structure, so that the essence of something and the existence of something is together. And so that's what we're trying to come up with. Is this is a simplified geometry where all you have to do is limit your scope to 13 different, what classically were called polyhedra, but really are containers. That they have an inside and an outside.
Right.
And so there's a way in which to define the simplest container, which is a four-sided container, the tetrahedron, like this little guy right here.
Right.
And if you take a rock and with a hammer and pound it into powder and then look at the pieces under the microscope, there'll be never any side that has less than four sides on it. Because that's how many you need for inside and outside.
For it to be a complete.
And so then from there you can say that these 13 containers are the simplest that exist. That you can't get any simpler than this. And so what we've tried to do is pack them all together so that you see that they're really just one model. And that they divide up, they're like Russian dolls that one fit inside the other.
Right.
Also known as the Platonic solids, right?
Yeah, there's all of the Platonic solids are in here, and some of the Archimedes solids are in there as well. But those, what's interesting about those is those were made by the ancient Greeks, and it was a very elitist, male-dominated, slave-owning society, and so they based all their order on uniformity. That nature, the most fundamental things are uniform, and the big difference with this is that nature bases everything on diversity. And that by ordering the geometry by how things look on the outside, get you into all sorts of trouble that you end up not being very efficient. Whereas if you start from the inside and out, which is basically what Fuller said, that you learn the center, and that you plug into the center and then it goes out in all directions. So that we've been trying to come up with all these cross-referencing matrices, sort of, you know, that you have a limit, and then there's all these different ways that you can get to that limit, and then they cross-reference each other, and out of that information, it self-organizes. So what this down here is that it looks kind of like a Greek coffee shop pastry shelf, right? And this is like the ones where they put the cake in, you know, and it rotates around. Here, so this guy fits right there, and so you see this is, everything has a spin to it. So this is one hand is 0, and the other hand is X. So you always have to put an X to an O. So you want to start putting some of these on? Because really what I want you guys to do is start playing with the models, and I just thought I'd give you
There's a chord behind you.
They're beautiful models.
Yeah.
Thank you.
Unbelievable. I can't wait to.
Are they just sticking together with that stickum, or are there magnets in there?
Well, no, it's rubber cement.
Rubber cement. And it remains kind of
Yeah,
vulcanized.
it's not the best.
Right.
You know, I really need another glue, and you can't.
Have you thought about magnets? I mean, it seems
Oh
like,
yeah, but it starts getting really complex.
Right, because they start pushing and pulling, huh?
And there's sometimes there's more than, there's like a tripolarity
Right,
instead
and
of
that doesn't exist, unfortunately.
yeah,
You need plus, minus, and 0.
yeah, something like that. But somebody who has a feel for that, for magnets, I think it would be really interesting, because there could be a way in which you could solve those problems. It's just that I've got so much on my plate that
Well, they're beautiful.
Yeah, they really
Very
are.
beautiful models.
I've been looking forward to handling them ever since you brought them out.
Well, that's what they're for. And for me, it's just this is just beautiful unto itself.
Yeah.
You know, that it's very evocative of biological life forms.
That's what this keeps
both of you are very clever in how you're figuring these out, because most people really don't have very much spatial literacy.
For sculptors.
Oh, well, that helps.
It helps a little bit. I'm still trying to figure out what these are derived from. Are each one of these radii essentially terminating at a how did you essentially, you said this was like everything you need to get the Big Bang, right?
Well, it sets out a structure in all directions.
Right.
So that if there is some kind of Big Bang, it depends on how much heat you put right here.
Mm-hmm.
So we're putting a ping pong ball, so it's safe. But if you put all the heat that exists in our reality, then you're going to get a really big explosion.
And so what do the points along the radii represent on this graphic?
So you look here, you can see where they terminate at the first limit, at this limit that's defined here.
Mm-hmm.
So this is the vector equilibrium with 6BB, and all of these here are that same vector equilibrium. It's the container. So you see the white ones are in the external locations here.
Mm-hmm.
And so they're in the same position as the centers of each one of these out here.
Okay.
So that's 12 of them.
Mm-hmm.
And then the yellow ones are in the midpoint
Mm-hmm.
of that. So that's in that space right there.
Right.
And there's
And
24 of those. And then the blue ones are in the center here of the triangles. And then the green ones are in the center of the square faces.
So it's basically like division, 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 division.
And then these are just continuing that. Let's see, that we printed out.
I think this actually, more than anything else, helps me see the concept of looking at shapes from the inside outward. Because I think I'm perhaps programmed to
Everyone is.
visualize the container, not the space within. Even if I can imagine that space within, this sort of depicts it better for me even than any of the volumes somehow.
Oh, that's music to my ears. And this is Fabiano's. He just today. Drywall.
Is that
and-
how you got it? Did it
Yeah.
look like that?
I think so, right?
Exactly.
Oh goodness.
Wow.